Hey guys, welcome back to another video. Today I'll be showcasing another Redstone computer that I've made. Now this is a different brand. It's called RayTrace, as you can see over here. And the last one is called Meltdown. But yeah, there are many updates to come, so don't worry about that. This is only version 1. There's a lot of things that I can change about this. Or I might even recreate the entire computer. I don't care. That's fine. Because this isn't a really good model because it's all crowded over here and it's all weird and looks like scribbles. It's kind of weird. But yeah, as you can see, compared to Meltdown, this computer is a lot bigger. It succeeds in size by a lot. It's probably twice as big. It still has 3 cores, so my computer in real life only has 2 cores, and this one has 3, which is weird. But yeah, version 2 might have 4 cores by a chance. Now, this computer only has addition and subtraction, sadly, so version 2, I'll definitely change that. I'll be adding XOR and OR and possibly multiplication and division, but if I added multiplication, you would only be able to multiply the first 4 bits because 8-bit multiplication is just huge. That would be an output of 16 bits. And there's no way I can fit that onto an 8-bit bus. And I want to keep it 8-bit. So yeah, the program memory, as you can see, there are the 3 cores, which are, well, you can't really see it, but there's one here, there's one here, and there's one here. So yeah, actually I can just go over here and show you to make it easier to see. So there's going to be 2 layers for each core. So this is 1 core, this is 2 cores, and 3 cores. So this right here is 16 lines of code, and there's 2 layers, so that makes it 32 lines. And I think that's enough. I mean, unless you want to plot a pixel on every single point of the GPU, you're not going to have enough to do that. And that is why I added a fill X and fill Y, which makes it a lot easier and doesn't take up as much space. So yeah, you have, these are the orange ones. Actually, let me start with these ones. This is the white, is basically the go-to system. So basically, I already have the torches put out here, so you don't have to worry about that. But that's the go-to system. Now this orange section is enabling and disabling the different cores. Now the blue is basically automatic input instead of manually setting it up over there. It still runs into the same input. Now the green is basically every register in the entire computer. So there's save the GPU coordinates, there's output data onto the parallel output port, enable output onto displays, there's read from the ALUs, bypass input onto output, and then the input stuff. The yellow, as I showed you earlier, is the addition and subtraction. Now the gray is connected to the master output bus, which is over there. I'll show you that in a little bit. So we have enable output onto input, which is basically, so over here you can, and it was in the green section by the way, you could save the input to a register and it would come out on the output instead of having to go through the ALUs. So you can just immediately take the input and put it on the output. If you want to bit shift. Bit shifting is very important for that kind of stuff. Now, if you want to do the random number generator, then, like if you want to do a random number generator, output a number from that, and then compute stuff with it, then I added this option where you can take the output and put it onto the input. So it's basically going back and forth. Now, what was left was the other gray ones was the bit shifting and activate random number generator. Now the purple and the magenta, the purple is writing to RAM, which is this giant block of gray. That's basically temporary memory or storage. So yeah, the purple is write and the magenta is read, and it all leads to a decoder, so that's why it says decoded 16 and 32. Now the pink is the GPU input, and it runs into a decoder as well. Now in version 2, I probably won't use a decoder so that you can plot more than one point at once, because that was the whole point of the whole thing, but I just ruined it by putting these decoders. But I wanted to try my best in saving room. So yeah, the cyan over here is the GPU control, so there's draw, erase, fill X, and fill Y. And the red is basically activating the indicators, which are, they can either be the overflow right here, or 2 minus signs, which means underflow, or they can be over here. So yeah. Now, let me show you how the computer works. So the blue goes in here, and then it goes through all these registers once you've saved it to it. And then it runs into these ALUs, and the reason why there's black lines is because it shows you the different cores. So there's 1 core, 2 core, 3 core. But those aren't the cores, those are just the ALUs. Every core needs its own ALU. So yeah, and now the output gets saved to these registers, and then you read it, and then you save it to RAM, and there are 32 bytes of RAM, and that's kind of a lot. I'll try to do 64 dual read in version 2, because dual read is very important, and I forgot that part on this. So yeah, once you read it, it comes out on the master output bus, and this is where it joins with the input. And you can bit shift left and right from here. And okay, stupid red line getting in my way. Okay, and then here's the random number generator. It doesn't need an input, it's just read only. Now here is the parallel output port, and it gets saved to these registers once it comes off. And you can also branch it off onto an AND gate that leads to this. Now this blue wire is basically coming from the program memory, so don't worry about that. And then it comes back onto the input bus, but it can also come onto this brown bus, which is more important than putting it back on the input, because how else are you going to display the whole thing? Well, it comes to this register, and then back out, it powers these lamps. And then it also goes into a BCD converter. Special thanks to Newellmaster for this design. I'm not sure if it's his design, but I saw his tutorial with this design anyways. And these are 7-segment displays. Now, this GPU thing, this whole thing was designed by Benny Scoob. So yeah, big props to him. In version 2, I'll get rid of these torch towers and replace them with slab towers, because torch towers aren't nearly as efficient, because it's 1 tick per torch. So yeah, that's about it for the user input panel and how the whole computer works. There's also these power controls. Make sure before you even input anything to the computer, you have to make sure that this is on. And what's cool about it is that there's a clock adjusting that you can adjust at the user input panel, so you can make it faster and slower, and etc. And that comes down here onto, or that clock comes down here to these registers and basically goes to the next line of code. So now I'm going to show you how to program all these cores. So basically, this is the first line of code, and let's say you want, on the first line of code, you want it to activate 16. What you would do, oh, I fell down. What you would do is place a torch here, so that whenever this is activated, it would, or when this turns off, then it would activate the 16 line. So let me get rid of that. Now, there should be a world download down in the description, because I made a huge mistake last computer on Meltdown that I didn't add a world download, and I deleted the whole world. not knowing that I didn't add a world download. So I had to recreate the whole thing, and this is what it turned out as. An even bigger and better computer. Now the big difference between Meltdown and this one is it has a GPU. The last one did not have a GPU because I didn't have enough room for one. But yeah, so here's the information. The date started was 10/15/2019. It's fully debugged, and these are the people that I give special thanks to. Benny's Cube, Proper English 19, Nuomaster, Nubosaurus, Legomaster 99. He's the one who inspired me to make my own computer. And Scoop It Up made the giant bluestone computer, you might remember him. And then, I don't know how to pronounce that, but he made the design for all the RAM cells down there. And Lawrence Wayne, she made the red game computer a long time ago. So yeah, please subscribe to all of those people. Now, this is an 8-bit processor, as you can see, because it's 8-bit right here. And it's RayTrace. The name of it, I decided to put RT14021, and then just this random version number. But the main number is version 1, the very front. And there's also RT1. I just tried to replicate the Intel logo and put it on there. And it also says it has a 16 by 16 pixel GPU, which is correct. It does have a 16 by 16. So yeah, and this is my YouTube channel, which you are watching on right now, so you don't have to worry about that. Anyways, so now I'm going to give an example of how this would work. So if you would put an input, so for say, this, you have to input in binary, sadly. So 1 plus 4 plus 8, so that's 5 plus 8 is 13. So you just put 13 into there, and make sure this is on, by the way. Now, originally you would activate Core 1 before anything. You can see the line down there just going about. It's going from line 1 to line 32, and then it restarts. So yeah, but I'm not gonna do that. That's just for an example to show you, because I haven't coded it at all. But yeah, you would put in the A input, but send input to Core 1, and then you can change your input for input B, so maybe 12. Now make sure that you flip this switch for input B, because off equals A, on equals B, and you would send input to Core 1 as well. Now you can turn all of these off, it doesn't really matter. And then you can select which operation you would like to do, and it would come out onto these. Now you can see there's an answer right here, but I haven't coded the program memory, so let's just say you coded it to where this would turn on as soon as you get the answer. It would come down to the RAM, you would save it and then read it, and then you would do something like bit shift or whatever, and then you would save it to this register, and then it would go to the output bus. So that's how you can use this thing. So yeah, and the nice thing about turning this thing off is that it resets every register in the whole computer. So earlier there was data saved in these registers, but now there's not. So that's a nice little feature I added, because this light blue is basically the power controls, and it goes literally everywhere, because there's pretty much registers all over the place, and it also connects to AND gates and everything like that. So yeah, that's my computer. I'm pretty sure that's all I have to say. So yeah, this is the raw binary system, and this is a 3-digit 7-segment display. So yeah, that's all I have to say. Thanks for watching. I'll hopefully put a world download in the description. If I don't, then scream at me, please, because I do that kind of stuff. I'm a terrible person. So yeah, thanks for watching. Hope you enjoyed, and I'll see you in the next video. Goodbye.